So, hi everyone, this is Salomon Kabongo. I will be presenting to you Listra with a user case from English to Lingala. So, this work was done under the supervision of Dr. Vukosi and Dr. Herman Kamper. So, let's get started. So, this is the agenda. We will introduce the work. I will talk about the dataset we created, discuss about the experiment a little bit quickly, and as well as showing you the result that we obtained, and conclude and see, talk to you about what we are planning to do next. So this is the introduction. So I will first talk about what is automatic speech translation. So this is the task of converting a speech, an utterance from one language to another. In this case, we're trying to translate whatever I'm speaking now in English to having a labs caption in Lingala. That can be any other language that you can think of. And the idea here, when you try to do this experiment, one of the issues that we face in low resource setting, for example in Lingala, where we don't have enough data, is there is the lack of aligned data, because here we can think of it like we have three alignment that need to be done: the speech, the transcription, the translation. There are many settings, but in these settings we have to be have data aligned in that specific format. So as you can think of the Bible, it systematically aligned. You can think of they align on verses level, and we have also the reading of the Bible. So we thought of just using the Bible as a starting point for trying to do proof of concept. And the traditional way of doing that is just doing the speech of the Bible, doing automatic speech recognition, and taking the result and feed it inside a machine translation model, and getting the translation of that the result of the speech recognition, and boom, we have a speech translation model. But we have also the end to end, where we have from the beginning and the end in the same model. We do the two things at once, and this has the advantage of not suffering from the error propagation. So let me show you just a demo of this idea, but implemented in Google YouTube's service. Let's look at it.
Okay, so we're back again with CS224N. So let's see. So in terms of what we're going to do today, I mean, I think it's going to be a little bit muddled up and going forwards and backwards. Officially in the syllabus, today's lecture is sequence-to-sequence models and attention, and next Tuesday's lecture is machine translation.
Yeah, as you could see, for those that are familiar with Swahili, the system, I don't know the detail of the implementation, but you can see that it's quite doing well in order in translating some of the word that are said in English in Swahili, for example. But our user case is how can we this be done in Lingala, for example. Okay, so let's go next in the dataset. So our dataset is made of these three tuples. We have the speech, the transcription, and the recognition. And for our user case, as I said, we just score the Bible from gw.org, this the rating in Lingala, and we have also the transcription in English, and the reading of the Bible. We took it from the Bible is. We didn't make it public because of the license, but we provide the tools. We can provide a tool for anyone to reproduce this setup for any language of interest. So we had to use the web mouse in order to split the speech and align it from the chapter level to verse level. Okay, so this is the result of our data. You can look at it clearly in our poster session. So poster 21, feel free to join us in the poster session. Okay, so this is the experiment setup for the cascade model as I explained. So here we have two models. We have the Cirolo model that does the speech recognition. We take the result and we put it in a standard transformer machine translation model, and we have a result. So this is how this looks visually. And we in the end-to-end setup that's a little bit different, because now we have one encoder and two decoders. One decoder for the recognition and one decoder for the translation. So basically those decoder are interlinked, and we used some approach in the literature that actually allowed for the decoder to wait a little bit, the decoder of the translation to wait a little bit for the transcription to happen before it can actually get enough context in order to do meaningful translation. So those are the result for the result session. So we pre-train and the pipeline model with GW300 for the translation model, but for the hand-to-end we pre-train also on the TED speech dataset in order to give it a little bit of a way to start knowing how to do speech recognition. So yeah, so this is basically the approach that I was talking about, the weight K, where we try to make the decoder of the translation to wait a little bit, and for this case, after waiting for with a parameter of 2, we had actually pretty much a result compared to weight 1 and weight 3. You can see the image here to see how this does practically. In conclusion, um, we work on Listra, we release the data set, and we provide us a tool to reproduce this kind of experiment with any language that is available in the Bible, obviously. And this, of course, it biased because it's the Bible data, but it a little bit good for proof of concept. You can prove any idea that you may have quickly with data that is actually available and naturally aligned. So we did both in pipeline and end-to-end model. So for future week, we want to extend it to include more other diverse data source and also pretend these two decoders before to do training on the proper the bigger data set. Thank you very much. That was all from my side, and looking forward to your question and discussing to you at poster 21 after this. Thank you very much. Bye bye.